All right. So in case again you see some issue, then just give me a call. Fortunately, I could find out this time. All right. So we'll study today the following things. We'll study IO devices. We'll understand what it is, and then we study two methods of doing IO. Okay. So far we have studied processor architecture, and then we studied cache memory. Following to that, we studied the virtual memory. Okay, now we will look at the next important concept. So, all right. So a computer in general, we can say have following components: control path, then data path. So data path design we have seen, data path of processor, and then how do we do control of the data path using control mechanism that we have seen. Then we have seen memory. Within memory, we have studied cache, and we have studied virtual memory. Okay, and today we'll look at two things together called input and output, right? So this is what our computer in general is, right? The desktop that we have today, that we use, uh, have the following components. So most of the computers, whether it's embedded kind or or non-embedded, there's a desktop kind of general purpose computer or laptop or something, have these components. That's kind of minimum that we have, right? uh, Input output may vary from one machine to another or one computer to another. Say for example, your embedded system will have inputs of different kind. Okay, and similarly output will be of different kind than what we have in case of a laptop. Okay, so input output devices or input output mechanisms may vary. Okay, so we'll look at some of these. So now let's come to this diagram, right, that we have studied in detail. This is exactly same as what we studied in case of five phase pipeline. Okay, and what we see here is large data path, and also there is some control unit. So control unit here is shown here, and then instruction fetch, instruction decode, and register fetch, and then execute, then memory, and then of course there is a write back. Okay, so all right. So with this one, uh, where do we see IO happening? Anyone?
So it should happen in the memory.
No, it should happen in the memory. No, your terminal or screen is not in memory, right? It's different. So we have not studied it, right? You are right to in some way that only IO that we have seen where process communicating something is memory, but memory is not IO. Memory is cache memory in particular, or main memory is considered a part of tightly coupled part of the processor. Okay, so okay, so in general, a computer system have following things. We have memory, we have data path, we have control. So memory is considered to be part of in general a computer system. Okay, because whether it's an embedded computer or any other computer, it will have memory tightly coupled. Input output can vary. Okay, so input output is something that to the environment outside we communicate. Say, for example, in our laptop, we have keyboard, okay, and then display. These are the two things that we do have in most of the machines that we are using. And also IO from networking, then you have Ethernet that's connected. Then you have Ethernet in turn connected to internet, and then you have disk. Okay, All right. So, and of course, we have mouse also, right? Some of us use mouse, some of us may not use mouse, right? But most of laptops come embedded with display and keyboard. These are minimum. Then we have something like mic and built-in mic and some speaker. Okay, so these are something that's minimum in any system. Okay, mouse is very important. What, input device or output device? Input device. Okay, and very interesting story around mouse. It didn't exist maybe 40 years back, 50 years back, right? The first computer that I have seen never had mouse. Okay, and then the guy who invented this, uh, Mr. Eaglebert, I don't know how to pronounce dog, or I don't know what is the pronunciation of this spelling. But Mr. Eaglebert was attending a conference, and then it according to him the talk was so boring that he started daydreaming and drawing something, and then he hit upon this idea of mouse. Okay, so sometimes while sleeping in a conference or class you may hit upon a good idea, although I don't suggest it to you. All right, so this mouse happens to be one of the very important IO device. I mean, I can't live without mouse, I mean, I try to buy the best possible mouse that's available. All right, so and then lot of IO devices we use every day. Say for example, what IO devices I may be using, you are also using possibly the same. Tell me, anyone can guess what IO devices I am using right now? Anyone? Actually, you
So
can
right
tell
now
me.
we are using a mic, maybe an Apple Pencil,
Yes.
then the screen and keyboard and stuff, and speakers also.
Abs- All right, very good. So I am using Apple Pencil, that's right, on which I can scribble. I am also using mic, that's right. I am using mic for inputting, speaker, a headphone speaker, of course, and of course I am using screen of iPad. Which is both IO device, right? Because I'm writing onto this, touch enabled. So I'm writing onto that. Okay, when you use Apple Pencil, and then I am also reading from that. So it's both IO device, right? So very good. And apart from that, I am also using some IO. Okay, I am also using Ethernet, right? Otherwise, data will not go, right? Data is reaching you through internet, but internet is the net that interconnects network. So IO works on top of sorry, the internet works on top of Ethernet, right? Because Ethernet is taking my packets, and then next layer onto that, which connects Ethernets, is internet, right? So I'm using Ethernet as well. Then something else I may be using. Okay, my Apple Pencil is also connected to my iPad through what? It is connected through Bluetooth. Okay, and so on. So these are something that we very often use, right? So these are the ones that IO devices we have in a laptop, and most of these, right? I mean, USB port, then we have Ethernet, Wi-Fi, Bluetooth, speakers, GPS sensor. Even on laptop you have GPS sensors, because in order for your Google map to work, it should know where you are. Okay, so GPS sensors are, then heat sensors are there. If temperature goes up in my laptop because of something, then it will do something, reduce the clock speed, or it may actually stop the machine, and so on. Okay. Similarly, mobile is a computer. Okay, it can be treated as a IO device also, right? I mean, for example, I use my mobile to send the data to TV. Okay, or I cast my screen to TV, right? So it can. Wi-Fi router could also be treated as a IO device. TV in general, I mean, if you look at the layman's perspective, it has it's just IO device and so on. Okay. Um, Now, input about devices, we say it's a common terminology used for input and output, but inputs are different from outputs. Okay, input is something the device takes in. Okay, and output is something which device. Sorry, input is something which laptop takes in from a device. Output is that laptop or computer gives to device. Say for example, keyboard and mouse are both input devices. There's nothing like output here. Okay, whatever I type goes to laptop, goes to the computer, and and similarly mouse, touch screen is also input device. It does not output anything. uh, Audio input, that's mic that I am using, is input device. Okay, while speaker is output device, camera will have also many input devices, and there are a lot of sensors like motion sensors, fingerprint sensors. These are all input devices. Camera in general, we can say it's in nowadays advanced cameras, we can say we can also see something that's happening, right? But in general, it's input device because it takes input from through lens and so on and creates image. Uh, all right. Then these input devices also changing the form. It's changing, right? It's not the same as it was earlier, uh, and lot of inventions are happening in the area of input or output devices, right? So some 40 years back, nobody would have thought that uh, these input outputs can happen from human body, right? I mean, for example, there can be temperature sensor or insulin pump or whatever, right? So nowadays the modern devices come equipped with large number of sensors which do some kind of input. Okay, and for example, the one that's showing here is a radar, tiny radar, which can sense the motion. Okay, and then it can be connected to a mobile. For example, here it's a Microsoft, sorry, Google Pixel, um, um, Google Pixel mobile equipment. To that, you can connect a tiny radar. It comes with, I mean, if you buy Google Pixel, then they come with a software which can actually once attached to some device like something, uh, here it is Pixel. Once you run the program, then it can work as a kind of radar, and you understand the concept of radar, right? I mean, radar throws some signal out, microwave signals, and then whatever is reflected back, it senses that and can find out if there is any object and what is the movement of the object. Okay, any question? All right, so this is and then as technology is changing, then large number of IO devices are coming. For example, in a car, automated car, right, which Google is making, okay, number of IO devices will be huge, right? A very, very large number of IO devices are there. Okay, and output devices, of course, are displays. Okay, I'm a display, for example, your laptop display, if it's not touch enabled. If it's touch enabled, also there is it's also an output device as well as input device, right? Similarly, audio output or printers, LEDs, RFID readers, all these things work as a output device, or it gives output. Where now output is used by whom? It can be used by human being like us, or it can be used by a controller or a machine attached to that, right? So if it's a machine to machine communication or a machine to machine interaction, then output of one machine can be used by other machine. All right, and so on. So this is a block diagram of general purpose computer. And then we have a computer that's attached to input device like mouse, keyboard, Ethernet, Bluetooth, and output are monitor, headphones, Ethernet, and Bluetooth. So Bluetooth and Ethernet both have input and output. Okay, all right. And then this is the block diagram of cyber physical system. You know, the one which we use in industry or a car, you know, and so on. So here, can you tell me this is cyber physical system for which, for what? Whatever it is using this cyber physical system, which can be modeled by this one. Any guess?
Self-driving cars.
Yeah, it's a car, simple, you know, motor car or car. And there's something called LiDAR. What is LiDAR? What is LiDAR? LI stands for light. Then light, D stands for what? Detection. Okay. Anybody? You can Google it. Okay, so this is light detection and ranging. Okay, so this kind of device that is used in basically finding out if there is an object in the range. So it basically, as I understand, it uses laser to ping off, to basically send laser to an object, and then you know, whatever return signal from that object you measure it. It works in the same principle as that of a radar. Okay, radar also, what we do is that we send very strong microwave pulse, and then when if there is an object, then we get the reflected signal, and we measure the strength of reflected signal to find out the distance of the object from the source. Same thing we are doing in case of LiDAR. Okay, and then we have inertial measurement unit. Okay, what is it? I mean, can you widely guess what it is like? Okay, so it's basically a device that can tell about the state of an object. You know, for example, it's what is the rate, angular rate, for example, or for example, what is the orientation of that? Okay, what is some kind of specific say speed or force or something, right? So it totally depends on what initial IMU or initial measurement unit is designed. But in general, we can say it's an electronic device that measures and reports body's specific force, angular rate, and sometimes orientation of body. So it's kind of in your mobile, for example, you have something called accelerometer. Okay, have you used that? Okay, that can give you, accelerometer can give you kind of velocity. Okay, and then we have something called gyroscope also in many mobiles. High-end mobiles will have gyroscope also. Okay, so these kind of things are there in IMU, and then of course there is a camera. Okay, and then CAN, which is a controller area network. So a most modern car that we use today, not really totally automatic Google kind of car, but even ordinary car has a large number of computers built into it, right? And actually number of lines of code in very advanced cars is actually more than number of lines of code in the mobile. It's nowadays cars are heavily advanced, totally advanced, wherein it's totally computer driven. Each and every part has some interface with computer. Okay, so and then we call it controller because the controller here, or embedded controllers, which are nothing but computers, in turn talk to each other. Brake, for example, brake unit might be talking to some sensor unit and some other, some other parts of the car, right? So the local area network for that we call as CAN. And output, of course, will be throttle control, brake control, wheel rotation, and so on. All right, so let's now move to the next one. Okay, and can you imagine laptop without IO? Okay, without screen, keyboard, Wi-Fi, etc., etc., it's of no use, right? So IO becomes very important part. Okay, it's like car without wheel. So IO is very important. All right. Now look at the complexity of the situation here. See, IOs are evolving. Devices are coming every day. Okay, even for example, the monitor or the screen that I bought for the first time. Actually, I brought the first monitor from USA when I went for my postdoc. I actually brought one monitor because monitor in India, that was very expensive. Okay, and it was pixel oriented monitor. Okay, and from there today the monitor that we have is extremely advanced. It's not only HD but higher HD. Okay, so it's very advanced nowadays. So even monitors have evolved over time, and similarly all other devices have evolved over time. And number of devices that today that are coming is very large. Every day you can find out a new IO devices coming into the market. Okay, so we can see that the IO devices that are shown here uh, just a minute. Okay, like keyboard is an input device. Okay, and who uses keyboard? A machine cannot use keyboard. A robot will not use keyboard, right? It is used by human being. And what's the data rate? The rate at which data can go, and maybe maximum speed, right? I mean, you are the best possible typist, and then you can type it at very fast pace, then your data rate would be close to 0.02 kilobits per second. Okay, and on the other hand, we have graphics display with high HD. uh, again, it's used by me, but the speed could be 8 order of magnitudes higher, almost like whatever this is kilobits, so this becomes megabits, gigabit, almost 3 plus gigabit per second. So this is the variance between the speed at which you know an output or input can come. Okay, and in between we can see there's a microphone, Bluetooth, um, hard disk drive, wireless network, solid state drive, and wired LAN. So the speed varies. So the IO system should be able to handle this kind of variable speed very efficiently. Okay, so, and as we mentioned, that speed can be a significant order of order of magnitude different. Okay, any question up to this point? Okay, all right, so we have studied this hierarchy several times, right? And then we see at the bottom, the shown here in yellow box are two devices, right? Solid state memory or flash drive that laptops have nowadays, or hard disk drive. Okay, and then from here, if something, we have seen just now in virtual memory, the hard disk drive or solid state drive has a copy of virtual address space, in some sense that all the pages that user address space will have are here. and that's what we call a swept space, right? At runtime, otherwise it will have files. Okay, so the question I am asking is as follows: disk is IO or memory? And actually answer we have given in the past. Anybody? While we use a common word memory for it, disk memory, for example, we very often we use a good word is of course storage, but this memory is also technically correct word. But with respect to CPU, can you say disk is a memory or is it IO? Anyone?
With respect to CPU, it should be IO.
Yes, very right. Why?
Because CPU takes the input from the memory and then do some register operations. So
Yeah, that's right. Okay, so you are right, absolutely right. So disks are actually IO. Okay, these are not memory. Now, see, one way of the way you answered is correctly. Reason is that within a cycle, memory gives uh, the data to CPU. Okay, when we say memory, in general, we are not distinguishing between memory, cache memory, L1, L2, L3, or main memory. In general, memory, when we say it acts at the speed of CPU. Okay, while disks are not memory because it, and for the way it is also treated is not like a memory. It's not connected to the same bus to which the main memory or cache is connected. Okay, so when we will look at that structure little later, and it is treated exactly as IO. For a CPU, it doesn't matter whether device that's connected is mouse or display or maybe Ethernet, right? The treatment is exactly the same. Okay, and usually the unit of transfer is large. Okay, so disks are IO, and then if you have the different processes, then the CPU always interacts with, this is of course address space or process, we can say this is address space, and CPU always works with memory. So this is RAM or main memory, or we can say cache. Okay, it's not visible to CPU whether it's a cache or main memory. So we can treat this as a memory in general. However, we can see there is a disk here connected, right? So CPU does IO, treats this disk as a IO device. Okay, all right. Okay, so very little about disk. Actually, I have sent you PPT. You can read through that. And disk, about disk, and also about flash memory. Okay, so that is self-contained and it's simple, right? There's hardly any thinking required. Just need to know how disk operates. In general, it's let's discuss in very brief. It's non-volatile storage. I mean, see, why do we need disk at all or flash memory at all? So disk is usually two types. Flash memory, of course, now, but earlier, 10 years back, people used to say disk is magnetic disk, like hard drive that you have in your laptop. Why do we need it? It's not something without which a computer cannot operate. I mean, a computer, a CPU requires main memory. Okay, and main memory is volatile. What or cache is volatile. Whatever goes into it, if retains into that as long as there is a power, electric power, right? And whenever there is no electricity or power, contents goes off. So it means that we also need a permanent storage where whether there's a power or not, things can remain, and that is the disk. Okay, so what we do is from the disk, at the boot up time, we bring everything from disk to main memory. Your program, for example, which is structured in a file, remains in hard disk. Okay, or it may remain in flash memory, and only at the time of runtime you bring it to main memory in a particular structure, right, that we have seen. All right, so these are of course long term inexpensive storage for files, and also we see that is very inexpensive or cheap. And there are two types of disk: magnetic disk or hard drive that we see today. Floppy drive is not in use anymore. Uh, and then we have flash drive, solid state drive or thumb drives, right? Solid state drive is in a laptop may come with solid state drive, or other, you can also have small flash pen drive that you connected to a port. All right. And we see that hard drive is mechanical in nature, right? Hence it is slow, but it can contain a lot of data. Okay. um, all right, so you can read about it from the PPT I have sent. Okay, so little bit so we'll not go into IO in big detail, right? In this class and next class we'll try to finish uh, about IO. All right, so what do we need for IO to work on, right? To work, first thing is that a weight. So why IO is actually needed? Okay, so basically there are large number of devices. Okay, and this number of devices are growing. What devices we have shown here is typically for a laptop or a desktop. Like we have a scanner here or printer here, then we have hard disk, then we have camera, then we have screen, um, and then we have something for game, I guess, and maybe a mouse. All right, so we all these devices need to get connected to the main processor, right? Or main processor or CPU should be able to communicate with any one of these. Say, for example, you have written a program and then you are expecting some input to come from keyboard. Okay, then then program or CPU is expecting something will come, right? So there must be a way for me to give input through keyboard, which will be read by CPU, and CPU is running a program. Okay? All right, and like at this moment we are doing video conference, and then there is a program running, video conference program running, both in my laptop as well as in a server somewhere, and that is expecting certain things from my side, right? Uh, Say for example, input to that whole program is basically through camera and mic, and output is through screen. All right, so there must be a way for data to be inputted to the computer or servers, and there should be way to control these devices, right? Like when I'm printing, then there should be way to for me to give control commands, right? Start print, or you know or change the format of the page to be printed, and so on and so forth, right? So there is need for control these devices. And of course, and if suppose printer says that paper jam, okay, then then that message should come to me on the screen, right? So it means that device should be able to communicate about some control messages. And of course there should be ability to transfer data. Whatever I'm printing should go to printer, right? Okay, so all right, and there should be way to present this input to the user program, so they are useful. All right, all right, so these are the three input requirement for IO. Any question? Is it simple? Any question, anyone? Okay. All right. I hope it's fairly simple now. Okay. All right. So input is essentially to read a sequence of bytes from device, and output is write a sequence of bytes to device, right? So these are the, we can now say that something, a sequence of bytes are coming from device is input for CPU, and then CPU is sending bytes to the device, that's output. Okay, and there are two ways of doing input and output. First is we can have instruction itself to do IO. In RISC-V, we have not used any instruction. But if you look at some complex instruction set like Intel instruction set, it may have certain instruction for doing input and output. So it may say that read from, I'm just giving a hypothetical example, read from keyboard or write to a device. Okay, so it can have certain instruction, like we have a very simple instruction like load and store. These are the only two instructions we had. Okay, um, to a memory location in RISC-V, right? But there can be many more, right? We can create an instruction which will say that go to a particular device and print this, or get input from the device, right? So there are some instructions in many computers, right? And earlier this kind of interface was very common, but very few machines use this nowadays, right? So we'll not look at these instructions that will do IO. Okay, now let's focus on something which is second type, which most of the computers do use today. Okay, what it says that we will not have any special instruction, but we'll use commonly use load and store instructions like load word, store word, load byte, store byte. Read to a memory location and write from write to a memory location and read from a memory location. That's all. Then question is that then how do we do IO with that? Then we can say that, see, when we do IO, we do IO. Sorry, when we read or write to a location, we have to specify the location, which is part of address space. Now we say that part of that address space is dedicated for doing communication with the devices. Simple. So that, rather than having 000 to FFFF, all the address space for memory, instead of that, say part of that will be reserved for IO. So when we say load word from that location corresponding to IO, then the device, whatever input that device has, we will read. And similarly, suppose a printer is mapped to one of that location, which is reserved for IO, and then we can say, when we say store word, it will go to a printer in some sense, right? So this way we can do IO. And it's very common method. And then now here what we can do is that we use registers. Okay, and writing to a register and reading to a register is like, if register has certain address, then we can write to that register through store and read to the register from register using load. Okay, so is, and this method we call it memory mapped IO. Okay, so it says that certain addresses are not regular memory addresses. Okay, instead they correspond to register in IO devices. Okay, and these are load and store. So using load and store, then we can read and write to the device. So for example, here in this example, we can use this area for regular main memory. Okay, and then this, starting from this address FFFF0000 up to say FFFF, we can use for IO. So in certain addresses we can, for example, the address here, which is FFF0000, we can map to say keyboard. Okay, and then we can have two registers associated, data register and control register. Control register is actually to check whether we can do operation or not. And similarly, data register is for transfer of the data, reading or writing. Okay, any question? Are you able to understand the memory mapped IO?
Sir, can you repeat it once?
Okay, all right, it's very simple, just think it this way. Okay, so we say that we are not going to have any special instruction for doing IO with any device. Okay, because number of devices are changing, their nature is also changing, right? So it means that whenever you come out with a new device, you have to add one instruction in some sense, right? Instruction type. Say, for example, if your instruction is write to a printer or read from, say, some device. Now, tomorrow you may have some advanced version of printer or new totally new device, right? Then you cannot keep on adding instruction. So that could be one reason why we don't have very special instructions for communicating with devices. So instead of that, what we can say that we will map a device to a memory location or to memory location, whatever. Say example, I have a laser printer and we say my laser printer is mapped to the location, say FFFF0001. So FFFF say 0001 for example. Okay, all right. Then so when I do read word, okay, sorry, so when I do load word, and then this address I give, say register, say R1 or S1, for example, S1, and then we give this address FFFF 0000 using, of course, some registers. If this address, then what are we doing? Whatever is there in this location, okay, and location, it means that it's pointed by a register. Okay, whatever is there in the register, I am loading it to bringing it to CPU and loading it to register S1. So essentially, I am reading from that printer. Okay, it may have some control information or some information. Similarly, when I want to write to a printer, then what I will do is store whatever, some word, whatever is there in the, say, register, say S1 or S2, for example, to then we'll say this location, say FFFF, say 0002 or 0001, if we structure it well. Okay, so let's say 0001. So whatever, it means that the contents of my register is going to a device register which is at this address. So it means that this address is mapped to a memory location which is nothing but a register in a device. Okay, so now we need to reserve different locations in this reserved area for different devices. And since this area is quite huge that we reserve, then we can connect to any number of devices that we want. Because we need to simply do input output to that register. Okay, is it clear now?
Yes, sir.
All right, so let's move ahead, right? So there are two, we note here there are two register associated with each device that's mapped to a location. Okay, which one is control register and second is data register. And here this diagram simply gives the memory maps. Say for example, and it's a part of the address space. Okay. So we say from 0000 to whatever here is reserved, or we do, this will be code and for something else and so on. And then we can say the starting from, say, say 0, for example, x0 to whatever 0x80000 is for flash. So let's see here, this area is reserved for flash. Okay, so it means then when you say load or store and give one address, it will what in this flash, it will go to that particular location, or that particular a register corresponding to that address. Okay. Similarly, memory for peripherals start from this address. So this address onwards for peripherals. It means that it's for say keyboard or whatever. All right. So in this way, once we reserve certain locations or addresses for devices, then we can do by reading and writing to that device. By reading or writing instructions, we can do read and write corresponding registers there. All right. So this is at very top level, right? We are not going to get into detail how actually it is implemented. Okay. Now, one thing we see is that there's a huge mismatch between processor and I/O speed. Okay. Say, for example, a common processor today works at 1 gigahertz. Okay. So it means that it can do 1 billion load and store instructions. Okay. It means that, and each, say, load instruction, say load word, for example, right? The unit of transfer is 32 bits or word, right? One word in 32 bits, right? So we can do in one cycle 32 bits of transfer of data between memory and CPU. Okay, so the data rate would be so much. Okay, basically 32 GB per second or gigabit per second, right? So this is the maximum speed load and transfer can done between microprocessor or CPU and memory. Okay. So, but devices, we say some of the addresses are reserved for devices, right? Say, for example, mouse will have a buffer associated with it, right? And it's given. So this is a mouse. So mouse will have one buffer, okay, which is mapped to some memory address. Say let's assume 0000, say f say A0. Okay, so this is the address, and so while processor can work at very fast speed and it sends data at this speed, then mouse can or so it may be expecting data from mouse at that speed which is not there. Okay, because mouse operates at very slow speed. Similarly, for any output device, say printer, it can accept data at certain rate. Okay, but processor can send data at very high speed. So there is a speed mismatch. So it means that when we design IO system, then it should take care of different speeds of different IO systems. Okay, it should not overwhelm. For example, if processor keeps sending data here to a printer, and buffer will be full in no time, and then there will be overflow. Okay, so this is an error condition which ideally shouldn't happen. So input output, when we design input system, we should take care of speed mismatch between processor and the devices, at the speed at which device can read or write. All right. So next move to, so now there is a need for checking whether device is ready or not to accept input or give output, right? And that is the objective of this something called control register. So control register tells the processor whether device is ready for the operation, whether it's a read or write. And there is a flag. Nothing, it's a control register is nothing but a flag which tells device is ready. Okay. And data register, of course, is for data transfer. Okay, because on printer we are printing something, so that's the data. Okay, so basically what processor can do is that it can check periodically this ready bit or this flag, and when in the control register, when it changes from 0 to 1, it means that that device is ready for IO. Okay, so if when it changes to 1, then we know the either its data is available. Okay, it means that if it is a output device, then is input device like mouse, then it means that mouse has some data to for CPU. Or in case of printer, for example, is ready to accept data. So whenever is 1, this control register, it means that corresponding device is ready for the operation, whether reading or writing. Okay, and then so this method of, it means that now processor has to check the status register before doing operation, and when this status register bit becomes 1, then it can do the operation, right? So this method of periodically checking the control register is called polling. Okay, all right, you understand? Anyone who has doubt about it? Okay, so for example, can you give real life example for this one, polling? Okay, say for example, you have a postman comes to your house, wants to deliver a letter, and there is a small box outside, right? So because nowadays, you don't want, postman to ring a bell, or it's also very slow process, right? The postman will drop whatever it wants to drop in a box. Okay, now if you have a small light there, or you have did some electronics, and whenever postman drops something there, then the light is LED will blink. Okay, so now you periodically go and check, maybe every 3-4 hours, if there is something is there, right? And if you get the notification, if the bright LED is on, then there is something, and you will take it out. So exactly the same thing will happen for a processor nothing but you. It will periodically check whether this control bit is set to 1. If it is 1, then it means that there is a data, and it will read the data from the box or the buffer. All right, so this method of yours, periodically going and checking whether something is there or not, is called polling. But is it efficient method or not inefficient method? Anybody? Okay, Devyani?
Sir, I think it will depend on the cost. If the cost of having to check outside is more as compared to having it a bit delayed after it has been delivered, then it would be inefficient.
Fine. Okay, totally depends on the operation, right? Say, instead of that, why can't you ask post, and you are not expecting these letters very often nowadays. Now, every 2 hours or 3 hours, you have to go out and check. And it's very unnecessary thing, right? If it's a once in a while is happening, why can't you ask the postman to just ring the bell if it happens once in a week? Right? Now, there's a difference between the two. First case, whenever you are free, or when periodically you'll have to, whatever you're doing inside home, you have to stop and go and attend. Okay, because you don't know what is whenever letter will come. In the other case, you will continue to do your work until you are interrupted by the postman outside. Okay, so there are pros and cons with that. So for example, if right now, let's assume that frequency of getting this letter becomes just too high. Okay, okay, you are expecting the number of letters every 10 minutes. Then you will say that maybe some method is better for me, you know, because you will get interrupts very often, right? So it totally depends on the scenario, but in general, this method of going and checking whether bit is set or not may not be efficient for certain cases, right? And we'll look at some of these. Okay, now of course before that we'll see that the method of checking this or polling is as simple as that, right? First instruction is, for example, we are reading from keyboard into register A0, right? Then we'll go to this location, which is this address gives you register of the device in keyboard, or keyboard is mapped to this address. Okay, so then you load the control bit from there. The control bit be 0 or 1. If there is a data available, then it's 1, otherwise 0. You load it to T0. Okay, so you first bring it to T0 and then, sorry, register T0 and use this address and bring it to register T1. So T1 will have either 0 or 1 depending on there is a data in the keyboard or not. Okay, and then you do AND immediate with 1 to find out whether 0 or 1. If it's 1, the output will be 1. Okay, then or if it's 0, then you keep checking when it becomes 1. Okay, when it becomes 1, you read it from there. So simple. Similarly for output, you can do exactly same loop for the output. Okay, now let's look at the another 2 minutes and we'll close. Cost of polling a mouse. We are coming to two cases where we say this method is good or bad. Okay, and we see that because mouse generates very slow data. Okay, then we will see that time required for checking whether data is coming, and we don't, and if for mouse we don't need to do the polling very often. We are going to do very slow polling, right? Once in, say a few milliseconds or something like that, depending on the characteristic of the device, which is mouse. Okay, and we see that number of, the percentage of processor time for polling is 0.012%, is very slow, very small compared to processor time. So we say this is okay. Okay, while in case of hard disk, okay, of course I am skipping all this. You can go ahead with this one. Okay, now hard disk is active sometime, but we don't know when it's getting active. So we'll have, and it transfer data is comparatively very fast pace. Okay. All right, so we'll have to do, and we don't want to miss anything, right? Because whatever data is transferred, we have to do it all, right? Because we, and 100% of time we can't keep CPU dedicated to read it from disk, because disk is even it's faster than other devices, but it's still slower than CPU. So now we'll have to check, almost like 400. Okay, basically 400 million clock cycles will be required for polling. Okay, and it is almost like 40% time of the overall CPU cycles. Okay, we maybe next time if we get time we'll read this, but so 40% of CPU cycles will be used to check whether disk is doing IO or not, or and this is not really acceptable thing. Okay, so if device is very fast, then amount of time, number of, and we need not miss anything of that transfer, then what is required is that polling should be very frequent, and each polling is going to take certain amount of time. For example, it says that each polling will require 400 cycles. clock cycles. Okay, so this is going to be take huge amount of time, then it's not acceptable. Okay, so we have two scenarios here. One is very slow and one very fast. Very slow thing, it works. When we are connecting very fast devices, then this method doesn't work. Then we'll say, why not postman come to our house and interrupt? Okay, then we'll come to next method called interrupt. We'll discuss this in next class. Okay, all right. Any question? Any question up to this point? Please go through this example. How does it work? Okay, and then because we'll use further extend this example for interrupt driven IO. But you can think of this example that interrupt is whenever, for example, printer is ready to print. It has printed previous page, for example, is ready to print. It will interrupt the processor. That's it. Okay, so we'll look at pros and cons of this method in the next class. All right. Thank you.
Sir,
Yeah.
sir, there was a request from like many of us that sometimes the net breaks down for like in between. So if that happens, so if recordings are available, we can refer back to them.
Yeah,
So-
yeah, fine. I will load it because it takes a messy work. I need
Yes,
to
sir.
edit it. So
Sir, as exams are approaching, many people requested me that they need time for like revision.
yeah,
So
I will try to load say 5-6 today because it takes about 2 hours for each lecture to clean up. Nevertheless, I will finish it off. But whatever we have studied, actually, it does not require truly video recording. And second fact is that not many of you are using video recording, right? Because if I see number of hits, it's less than 10 for most of the videos. So actually, it's not being used effectively. But nevertheless, I will upload it.
okay, sir. Thank you, sir.
All right. Thank you.
Sir, also